Hey, good afternoon, everybody. I hope everyone's having a great day, a great week. I'm Maureen Gribble here with UE Systems. I'm really excited today to dive in on our OnTrak SmartLube. So we've got Sean Johnson, who is one of our regional managers. Those of you in the Texas, Oklahoma, Arkansas area have probably spoken with him or worked with him. But he's really excited to share with you all about this solution that we've had out for a little over a year now. So we're kind of talking all the ways that we are reimagining bearing lubrication, and we're pretty excited about this. The folks that have implemented this at their facilities and doing some pilot programs and things like that, it seems to be something that people are really excited about and getting some really nice results. So hopefully you all can, learn a little bit more about it today and be thinking as you're listening to Sean of different applications where this might fit in at your facility. And yeah, we just hope to kind of get you jazzed up about it. So before I turn things over to Sean, just some housekeeping, typical stuff. We are going to record this, so if you have to hop out early, you can definitely catch the end of it if you want to share this with anybody, if you want to revisit it to kind of get questions answered, things like that. So we are going to record this. We'll put it up on our YouTube channel probably later today. We'll have it up there. We definitely welcome questions, so definitely don't hesitate to type those in throughout the presentation. If it feels like it's a question that I need to kind of stop Sean and get him to clarify something, I will do that during the presentation. Otherwise, of course, we'll have some Q&A time at the end. If we don't get to all of the questions, we will for sure, Sean will follow up with everybody afterwards, or the right person if it's a question about something different. We'll be sure to get you hooked up. We also have some poll questions throughout, so just try to make this interactive as best we can, knowing that we're all kind of spread out throughout the country and globe, perhaps. And of course, like we always like to say, just pardon any noise issues, dogs barking, things like that, any technical difficulties. If one of our audio drops or internet, we are doing this live, which we find a lot of value in, but of course that opens us up to potential little mishaps. So just know that we'll jump on it as quick as we can and bear with us. But with that said, I am going to turn the slides, the presentation here over to Sean. And Sean, we will let you take it away.
All right. Well, thanks again for the introduction there, Maureen. I appreciate it. But today, obviously, we're here to talk about bearing lubrication and how we reimagine bearing lubrication through the only condition-based automatic lubrication system. Let's go ahead and get started. So believe it or not, there was a study done by SKF a few years ago. Of course, there's various other studies done out there by several other bearing manufacturers, but what we found, or what they found, I should say, was that 80% of bearing failure is attributed to lubrication-related tasks. So let's go through that. So obviously, we're going to have premature bearing failures due to some things outside of bearing lubrication. However, 80% makes up a good majority of that premature bearing failure that we do see today. I mean, let's go through it. Insufficient lubricant quantity, we're at 15%. Are we getting enough grease? Maybe it's not enough grease, we don't know. Long time without renewing, okay? That's part of the using that whenever we get around to it lubrication phase. Unsuitable lubrication. So maybe we're grabbing the wrong grease and we're putting in the wrong grease type into some of these assets that require a more specific type of grease type. Lubricant contamination, 25% makes up of that premature bearing failure. These are all the things that we're focusing on using the OnTrak SmartLube system as the first, and again, the only automatic lubrication system. So when we think about traditional condition monitoring programs, we often think of the P to F curve or I to P to F curve. How quickly can we detect that onset of failure? So like we discussed in the last slide, 80% of bearing failures is lubrication related. Again, because it all starts with bearing lubrication, that is the area that we want to focus on so that you don't have to worry about bearing failures in the future. So let's look at the evolution of bearing lubrication, okay? And we'll start from the number 1 and work our way to 5. So on number 1, that's what we like to call the whenever method, okay? I'm sure some of you are familiar with this term, you know, whenever we get around to it, whenever we get a chance to lubricate bearings. You know, obviously we're not doing any kind of condition monitoring or using any calculation. We're just getting to it whenever. The next step up above that would be your time-based lubrications, or I'm sorry, yeah, time-based lubrication. So this is what I also like to call the assumption method. So depending on where you're at, I'm sure some of you probably use some type of calculation on some of your assets on the frequency of you going out to go lubricate a bearing. That is that time-based lubrication. Again, using some assumptions, we have to assume that we've got the correct temps, we're assuming the load, and we're assuming the RPM just to get those calculations. And if we're just assuming that, then we're really just assuming that we should lubricate these bearings on that time frequency. Taking it up, step notch up, would be the condition-based monitoring, right? So some of you, or probably the majority of you, are familiar with condition-based monitoring, especially if you're already using ultrasound. And it's very simple. We're going out there on a time base to collect data, right? To see that friction level of the bearings. And depending on the condition of that bearing, seeing that increase in friction, we will lubricate that asset at that point in time. Now, again, of course, we've got that gap in between data collection, and we're not going to be able to see if there was anything that occurred in between that data collection. So let's take it a step further. We've got automatic lubers, right? Now, you are avoiding contamination by going into the automatic lubrication. However, you're still time-based, okay? And again, you're still using that assumption method, assuming the temps, the loads, and the RPM to get that time frequency of that automatic luber. And of course, finally, the OnTrak. Now, what we did with this is we combined it with ultrasound in real time with automatic greasing based on friction rather than time. So now we can say that we can monitor bearings and grease bearings from anywhere at any time. Now, when we think of the OnTrak system, obviously, most of us are going to think of the box, right? That's what you've seen in the invites, the pictures. You see the box in the background. It's got the label on there that says OnTrak. Well, what most people don't realize is that it's the 850 sensor. You guys see here in this picture, the 850S sensor that is the heart of the system. Well, why, you might ask? Well, that is what is actually measuring that friction. By measuring that friction, we're going to know when friction has gone up and know how much grease is required to restore that bearing back to the baseline friction level. And best of all is that we're getting those friction levels in real time. Now, without a system like this, typically we're time based on month to month, right? What we don't realize is that there is slight damage occurring every time we delay that bearing relubrication. Whether it's overgrease or undergrease, we are causing that slight damage over time. So by having the heart of the system measuring that friction level in real time, we're able to avoid that delay and potential damage over time. Now, when we look at the 850S sensor, we designed the sensor for purpose to measure those frictions, the friction levels of your bearings. Now, the sensor is a stainless steel sensor, IP67 rated for all weather. We have these sensors all the way up in northern Canada. I think, as a matter of fact, it was negative 47 degrees Fahrenheit where we've got some of these systems installed at, all the way into the southern parts of the US. The sensor has a dynamic range from 0 to 100 decibels. Of course, having that ability is going to allow us to pick up on the smallest change in friction. And if you're already a user of ultrasound, you guys are already going to know about sensitivity adjustment, right? It's one of the things we stress on. This sensor has a microprocessor in it that will automatically adjust the sensitivity for you regardless of your application or bearing speed. So before we move on and talk about the single point lubricators, I did want to ask you guys a question. Are you currently using auto lubricators at your facility today?
All right, so I'm going to just launch this poll here, and you guys can take a second here to answer this for us. So we'll kind of give it a second here. All right, we got some votes coming in. Looks like it's split with just a few more folks having them than not. Oh, now it's flipped to the other way. So, but it is pretty close, like 46% yes, 56% no. So
Okay.
there you
Okay.
go.
All right. Well, thank you. So good. So almost half of you guys are using automatic lubers. Okay. And maybe on the side, you guys could share what your thoughts are about these automatic lubricators. And the reason why I ask is because we did do a poll of customers who have used these before, and what we found, it was actually a love-hate relationship. People are definitely using the auto lubricators, however, they're only using them in areas that would be deemed unsafe or inaccessible for one of us to get to. So they may have been used on other applications before, but what ended up happening is customers had to put in another PM just to make sure their lubers are working. Okay, and I've seen this in my territory, and I'm sure you guys have seen that where you're at. So with that, we wanted to design with a goal of confidence. So when you're at home or across the globe, you will know exactly how much grease is left and how much grease is being used. Oops. As we know, you won't be able to mount the lubricator directly to the asset, maybe sometimes for safety, vibration, or other work processes. We also designed the sensor to be able to be remotely mounted up to 20 feet away. Okay, now that 20-foot grease extension will come pre-filled with the grease that you're going to be using as well, so no need to worry about filling that grease line before you hook it up. We also designed a lubricator to detect back pressure. Okay, there are various reasons we would get back pressure, whether it's a kink or clog or it got pinched somewhere along the line, but we do have that ability to detect the back pressure to protect the lubricator and bearing from any excessive back pressure. So for the first time ever, from anywhere around the world, you can ensure grease is definitely reaching those bearings. And we do that by measuring the friction and seeing that friction level drop in real time. These are not the same automatic lubricators that you guys are used to. Some of the highlights of the single point lubricator, obviously it's a dedicated lubricator with its own dedicated pouch that we can obviously use any type of grease that you're currently using at your facility. And you're not limited on grease types either. Now, we're not a grease provider, but we'll definitely work with you to ensure that you guys are getting the grease that you're currently using at your plant today. Best of all, it's contaminant free. When installed properly, you don't have to worry about dust or water entering the grease. It's also a smart lubricator with an LCD screen, as you can see there. It's going to allow us to configure that single point lubricator. This lubricator also has a maximum output pressure of 850 PSI. Now, this doesn't mean we're pumping, 850 PSI of grease into the bearing, but this is going to allow us to remotely mount it up to 20 feet away. And what this lubricator does is it has a ramp up method. So it's only going to output the pressure required for to grease that bearing. So we took our 850 sensors and single point lubricator, and we coupled it with IoT-enabled communication. So providing insights anywhere at any time. And when we developed the UE insights, kind of like what you guys see here on the screen to your right, we developed it with one proposition in mind: simplicity. We designed that user interface so that it doesn't matter if you're a planner or a supervisor or leader who might not have that technical background, but you're going to be able to look at that user interface and easily interpret that data and understand what's happening. Now we'll go through we'll go through this in more detail as later on slides, but you know, for the moment, let's go ahead and look at what we see here. Okay, everybody can see the squiggly line, right? That is our actual friction level on this particular system. Now, if you follow that blue line there, you can see that it kind of drops off there and goes back down to this dashed green line being our baseline level, our baseline friction level. And we can see that by automatically hitting that SmartLube assist, that lubricator applied just enough grease to bring it back down to its friction level. And at that point, you're free to go. And of course, what's best of all is all this information is going to be stored historically for the life of that machine. Now, understanding that insights is the new goal, of course, but what we wanted to do was not own your data. We don't want your data. We want you to own that data and get it to wherever you need it to go. So admittedly, the data is going to go into our UE insights, but if you want to bring that data over to your existing PLC or historians, you can do this easily, license-free. Connect that data into your own system. It's your data. Okay, now there's going to be 3 ways of communication for this OnTrak system. You're going to have Wi-Fi, Ethernet, or cellular. Wi-Fi and Ethernet obviously are going to be using your existing service there at your facility. Now, there may be some hurdles depending on your IT to be able to get this onto your network there at your site, which can be a hurdle. So we do offer that cellular option. And that is what's truly making this OnTrak system plug and play. You just plug it in the wall and it's ready to go. We also have Modbus TCP integration. So it's the most widely used protocol to bring the data from your OnTrak to your existing automated control system. We also built in REST APIs. So for more integrated connections, everything can be exposed through the REST APIs. Now, as of right now, we've got about 1,500 sensors and lubricators out there monitoring friction levels and lubricating bearings, restoring those friction levels. Now, we have to ask ourselves, you know, what have we learned? What are the benefits that we found by using the OnTrak system? And what we found was, on average, we saw a reduction in grease consumption up to 30%, okay? Now, what we also learned, and this is really interesting here, to keep that bearing at an optimal friction level, it's actually going to require grease more frequently, okay? Now, it sounds counterintuitive to probably what you're used to. However, the quantity is going to be drastically reduced. So with the examples that you're going to see here shortly, we have as little as 0.3 cc's of grease going into a bearing to restore optimal friction levels. Now, to date, we've seen a 65% reduction in premature bearing failures. Okay, now this isn't the main benefit that we're being told though with the OnTrak, and what this really surprised us. It was the decrease in lubrication related tasks up to 95%. So no longer do you have to go and grab your grease gun and hopefully you grab the right one, go walk out to your field or your line, lubricating your bearings, manually greasing those bearings, or even collecting data, right? And that could be that non-value added task, that person actually going out there and walking out there and spending that time out there to grease. Now what we can do is you can spend more time in areas where value is added. So here's a quick overview of the components of the OnTrak SmartLube system. There, obviously, you guys can see the OnTrak itself, the edge analytic device. That's what we'll consider our gateway. Very simple. All you have to do is plug it into a wall outlet. It requires 124 volts, and it's ready to go. It's IP67 rated, so you can have this thing inside or outside, rated for all kinds of weather. Now, we coupled that OnTrak with our 850S sensor and the single point lubricators, and of course, our UE insights. Those are pretty much the main components of the OnTrak system. There's really not much to it. Now, the OnTrak system will monitor and lubricate up to 16 bearings. This is a modular system and is designed to fit your needs. So you can have it set up and just to measure friction, or have it both friction and lubrication. Any combination up to 16 independent bearings. There's also no limit to the number of OnTraks you can have at your facility. So again, you can have that modular system. Yes, 16 points per OnTrak, but you can have multiple OnTraks at one site. Now, when we built the UE Insights, we built it mobile. Being web-based, you can go into your UE Insights from either a tablet, a phone, or even a computer. Best of all, it's not licensed by the number of users or dashboards, and there's no software required to get this to work. It's all web-based. Now, those of you who are familiar with condition-based monitoring with ultrasound, we do have some built-in alarm levels that we'll establish based off of our baseline friction level. The first one being an 8 decibel increase from our baseline level. If we do see that 8 decibel increase from our baseline, this is an indication of lack of lubrication. Now, we're not seeing physical damage yet, but hey, at least we're being notified to lubricate this bearing. Okay, whether it's with manually being greased using that notification from the OnTrak, or using a SmartLube to grease that bearing. Next would be the 16 decibel rise above baseline. Those who are familiar, that is the point where we hit that failure mode of the bearing. So yes, we can probably throw some grease at it and bring that friction level back down. Just know that grease is not going to fix it, okay? That could potentially go back up because again, we're already in that failure mode. Now, if we're seeing 35 plus decibel increase from our baseline number, now we're talking about critical failure. Okay, this machine or asset can go down at a moment's notice and probably should be dealt with ASAP. Now, when it comes to prescriptive insights, okay, I'm sure you guys who are looking at this right now, it doesn't take long to figure out what's going on. We wanted to design this in a way that was easy for you to understand. So I think you guys can understand the value of something like this for someone who might not necessarily have that technical know-how. So imagine if you guys walk into your, let's just say you walk into your shop, you've got the monitor up on the wall and you can see your assets with gauges similar to this. You got 100 of them on. And we can look at one gauge and see, as we can see here, like this one, we have a bearing that's reading 28.7 decibels. That's the friction that's our current friction value. Our baseline friction value is 26. Now, as we can see, this is a healthy bearing, so there's no action for me to take. Now, imagine if that gauge was pointing straight up, right in that blue area, right? That is now indicating that the bearing needs lubrication. So what's great about this system is that when you do start to apply that grease using that SmartLube Assist, it's going to apply the grease slowly. Now, if you might have this on some pillow block bearings, it's actually not uncommon for those to take 20 or even 30 minutes to grease. So what happens is it applies a small amount of grease, it waits for 5 minutes, it looks for a change in friction, and then makes a decision whether to apply more grease or to leave it where it's at. What's even more amazing is that you're going to see that gauge that you see on the screen there move to the left in real time. Now, here's some examples of the single point lubricators actually installed on some customers' assets here. There, the picture on the left, we can see that the single point lubricator is mounted directly to the asset, which is an option for you guys, provided that there's enough space. right? There's not a lot of vibration taking place, and it's not impeding on any work processes. You can have it mounted directly to the asset. Now, if you do have some of those issues, you might want to look at something to the right. So that is an example of our single point lubricator remotely mounted. Now, you can get remote mount kits, and again, like I mentioned before, we have that grease extension line up to 20 feet that's already pre-filled with your grease, so no worries there, but you do have the option to remotely mount this, and that's what it looks like. Here's an example of some sensors mounted. You know, there's really not much to it. You can look at the sensor at the left. I mean, it's not pretty, obviously. It's not perfect, but it works, right? And that's what's great about the system. It's so simple to use. There you go. The sensor on the left, it's mounted on a typical pillow block bearing. Nothing fancy about it, but we know, hey, we can now monitor that bearing. Now, looking at the asset to the right, those of you who are familiar with ultrasound and condition monitoring, we don't want to gather our readings off of the fan shroud, right? Because we're going to pick up all that background noise from the fan. And typically on something like this, we might not have a good solid connection to mount that sensor to. So like you guys can see here, I don't know if you guys can see that, right below the sensor, in between these cooling fins there is our fin mount kit. And what's really cool about this is it's almost like a stethoscope or a waveguide that's now making a good solid connection, and now we have a good mount for our sensor to listen to that bearing through that housing. Next will be the OnTrak. There you go. You can see the OnTrak mounted on the wall there on the left picture and the right. Now, not much to it. The box there, it's going to come with the mounting kit for you to be able to mount it on the wall, either interior or exterior. The customer on the left there, you can see they dressed it up real nice with the conduit and made it look real nice. The wires coming into the bottom of it. There on the right as well, you can see that they just mounted it right next to the single point lubricators. So anywhere that you're going to be able to have access to all the assets and having the length required to be able to go into that OnTrak. Now, let's go ahead and look at UE Insights right quick. And actually, before I continue on, I got one more question for you guys. Are you currently using ultrasound?
All right, here we go. We're going to launch this one. So just curious if you're using ultrasound or not at your facility. So we'll take a second here to see what we got. I would imagine it's a pretty good chunk of folks using it since that's who we emailed about this. So actually we're at about, looks like it's leveling out here, about 61% yes, 39% no. So Sean, we got a to-do list when we get off of here.
That sounds like it. Okay. So those of you who have used ultrasound before, and I'm sure you can look at this, you're going to already know exactly what you're looking at. Okay, and that's part of having the intuitive, simple type of user interface here when we're looking at something like the UE Insights. For those of you who have not used ultrasound before, I'm sure it's going to be really easy for you guys to figure out. Now, I don't know if you guys can see that green dashed line there. It's kind of hidden behind those yellow squiggly, or I'm sorry, not yellow, the blue squiggly line there going across it. But that green dashed line is our baseline number. Okay, I'm sure you can see that it's indicated with the arrow. The 8 decibel increase from that would be our blue dash line, indicating lack of lubrication. Of course, 16 plus being the yellow, now we're entering physical damage, and of course, critical failure, we're looking at 35 plus. And as we can see here, by looking at this screen, we can see those readings, right, with that blue little dots there, the squiggly line. Because that squiggly line is majority on that baseline level, that is telling me that what we're looking at here is a healthy bearing, and I'm sure you guys would agree with me. So wait, doesn't friction change based on varying speed conditions? Yes, but here's the misconception. If we have a good bearing on a variable speed drive, and I know this question does get asked, especially when we're doing EOS with customers, you will see an increase in decibels, right? But if it's a healthy bearing, we're only going to see roughly maybe 2 or 3 decibel increase when that motor ramps up, or if the asset ramps up. Now, if we're seeing an exponential increase in decibels when we're talking about variable speed, and we're seeing double the amount of friction level there in decibels, now we're probably talking about something that is damaged. And I've got an example for you guys to see that here in the next few slides. So here's a slide showing under lubrication or under lubricated bearing. Really simple. They're on the left-hand side. You can see that that squiggly line is above that baseline level. Okay, we were reading an initial friction reading of 14 decibels. They went out there, applied 15 cc's of grease, and they were able to bring that baseline friction level down to 11 decibels with a peak to peak of 3 decibels. So there you were able to see that change even on the UE insights. And again, it's so intuitive, it's really easy to just understand that. Here's a friction trend of under lubricated bearing using a single point lubricator. Okay, so following that squiggly line from the left and moving right, we can see that it is above that lack of lubrication line. Okay, so the user at this point has received a text message and an email alert saying, hey, you're an alarm. So all the user has to do is log into the UE insights. They'll verify that the information is correct that they're seeing, right? Hit the SmartLube Assist button, and then what you're going to see there, I don't know if you guys can see that drop there, it's going to drop back down to its baseline level, and it did it automatically just by hitting that SmartLube Assist button. We were able to restore that friction level back to its baseline level. Very cool to see. Here's another example of under lubricated bearing. Now this was done with the manual grease gun. So like you guys heard me say before, you can have the OnTrak without the single point lubricator. So you can still get those live alerts. In this case, they just using the sensors to measure that friction. They were able to go out there with a grease gun. And by the way, they used their cell phone for this. They logged in through their UE insights. They saw that trend on their cell phone, and they were able to lubricate that bearing on the spot remotely on their phone and watch that friction level drop in real time. Next, we've got another manually lubricated bearing here using the OnTrak system. There you can see it kind of looks like we've got some impacting involved there on the left-hand side. All right, but what's really crazy about this particular bearing is when we were gathering this baseline friction level, all they had to do was put in a shot of grease, and magically you can see how much that reduced that impacting that was taking place within that bearing. So very intuitive and easily able to read. Just by simply looking at it, you're going to know what's going on. All right, guys, so here is another particular under greased bearing here using this single point lubricator. Now, obviously, this one being a little bit different, as you can see there on the left-hand side, it is actually dipping into that failure mode. But I don't know if you guys can see there, when they got the notification, their starting friction level was 29.6 decibels. Okay, so almost 30 decibels. By hitting that SmartLube Assist, they were able to bring that friction level back down with their ending friction level being 16.7 decibels. It only required 7 cc's of grease to bring that friction level back down. So very little grease. So here's a really quick quote that I like to show the customers. It pretty much sums up the OnTrak system and what you might encounter if you guys did move towards something like this. So it was extremely easy and very impressive. So all the guy had to do was just log in and see what's going on. He was putting his son to bed. He got a message from the system, logged into his phone to verify the readings. He pushed the SmartLube Assist button, monitored it for a while, then eventually forgot about it, came in the next day, and he saw that friction level being restored back to its baseline level. Okay. And of course, one thing to say he says there is he's impressed that this is the future. I don't know about you guys, but I think it's the future too. Now, with that being said, let's go ahead and look at some bad bearings. All right, what bad bearings might look like when you're using the OnTrak system. So here we can see that our baseline level should be at around 2, 3, maybe 3 decibels, right? But here we can see that those readings are jumping all over the place, and they're really falling in between that failure mode and lack of lubrication mode. When we typically see friction levels jumping up and down like this, this is an indication of a failed bearing. Next, we're talking about variable frequency drives, right? So like you heard me mention before, we should only see that 2 to 3 decibel increase when that asset does ramp up. But if we're seeing an exponential increase, much like what we might see here, right? Now we're probably talking about physical damage to the bearing. It may require us to look at it a little bit closer. But here you can see that when it's ramping up, that we're well below the baseline level, but when it ramps up, it's going up into that lack of lubrication mode. And it goes back down, back to below the baseline level, and it's ramping back up into the lack of lubrication mode. So what we're seeing here is an exponential increase in decibels. And when we do see something like this on a variable frequency drive, it could be an indication of a failed bearing. Now here's another example, right? So starting from the left, this is a bad bearing. You can see that the baseline friction level should be at or around 2 decibels, right? In this case, though, starting from the left, it looks like we're reading at about 22, 25 decibels, right? So we're well beyond that lack of lubrication, and now we're looking in a failure mode. And you can see that the user did get the notification, and when they did apply the grease, they unfortunately were not able to restore that friction back to the baseline level. They were only able to get it to that lack of lubrication mode. So if we're seeing something like this after grease has been inserted, there could be the potential for a failed bearing, or we had an improper baseline, but it's something that we can take a look at, and we're going to know just by looking at the insights. Here's a really good example for you guys. So looking at this, right? Look at the picture to the right. Okay, we can see that the bearing is obviously in that failure mode. Okay, we can see this trending above that yellow line. Okay, so the user got the alarm notification. You can see that the grease went in. That friction level dropped back down to the baseline level. But is it fixed? Right? Again, it's in that failure mode already. So he applied that grease, brought it back down into that baseline level. However, when a bearing has failed, grease will only, I guess you should say, help reduce that friction level. But once it's failed, it's failed. And here you can see 4 hours later, we're already back into the lack of lubrication mode. So anytime you see that you're trying to fight that baseline number, we're probably dealing with a failed bearing. So here's that same bearing, even after multiple attempts to bringing that friction level back down to the baseline level, and it just keeps climbing like that. Again, if you're fighting that baseline level, we're probably dealing with a failed bearing. You might have to do some further investigation. But again, you're going to be able to see that live in real time, much like what you see here in front of you. So bearing lubrication and health monitoring made easy. So in column number 1, right, like we saw in the first slide there, the friction levels are very consistent. It's pretty much a flat line straight across that baseline friction level. And that would indicate to me that we're looking at a healthy bearing. Looking at block number 2, right? We're looking for peaks and valleys, right? Less than 4 decibels in amplitude. Here we can see that the readings are all over the place, okay? Bouncing around. We're above that lack of lubrication mode. We're definitely dipping into the failure mode. So here it looks like, based off the friction readings, that we're dealing with a failed bearing. And of course, finally, number 3, we can look for that increase in friction over a 30-day period, right? So as an increase in friction over time indicates the bearing is not healthy. So if we do lubricate that bearing, and again, we're having to fight that baseline level and bring it back down, it just ramps back up. Again, we're probably dealing with a failed bearing at that point in time. And these are some insights that you guys would be able to see just by looking at your insights. So with that being said, that is, in a nutshell, how we reimagine bearing lubrication, again, with the only condition-based automatic lubrication system. Now with that, I'm going to leave you guys with one last question here for you guys, and I appreciate you guys answering these for us. Let's see here. Where was it? Are you guys interested in learning more about the OnTrak SmartLube system?
All right, so we'll just throw this one up here and let folks take a list or answer, and then we'll dive into your questions. So if you haven't asked one yet and you've got one, pop it into the little questions box here, and we'll get to the ones that we can. And like I said at the beginning, we'll for sure circle back offline. So, all right, good, Sean, you did great. We've got a lot of people interested in learning more. So we'll close that out and. So some questions here, and this is a question we get quite often when we're talking about anything to do with ultrasound assisted lubrication, whether it's with our handhelds or now with this OnTrak SmartLube system. But Sean, maybe you can talk a little bit about how we handle baselines. That's always something people, well, how do you get baselines on my bearings if they're not new? Da, 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 da. So maybe kind of hit up a few pointers on how we kind of look at
Right.
baselines.
Right, and there's been some discussion in how to get an accurate baseline reading, because obviously in a perfect world we would start with brand new bearings on everything, and we all know that that's not conducive for our type of environments and the facilities that we're working at, especially with the manning that we're dealing with nowadays. So there's some ways that you can establish a baseline reading by simply just watching the friction level. Put the 850 sensor on there and watch that friction level and see what it does. Okay, depending on when the last time it was greased, you could try to throw some grease at it and see if we do see a decrease in decibel numbers. And if we do see a decrease in decibel number, we can then update that baseline number from there and trend off that baseline number. But probably the easiest that we've seen is just taking the reading as is and measuring it from that point forward. Now, like I said, if we do apply a grease there and bring that baseline lower than our initial baseline reading, we'll just make that our new baseline reading. But yeah, you just put the OnTrak on there. We'll get our initial reading, and obviously we're going to work with you guys to establish that baseline reading. So we're not just going to leave you high and dry. So we're not just going to say, hey, okay, there's the OnTrak. Okay, good luck. No, we're actually going to work with you guys. We're going to log into the UE Insights. We're going to go through each of the points, look at those friction levels, and maybe help determine what that baseline level is. So we're not going to just leave you guys high. How should I say? We're not just going to leave you to hang out and dry. We're going to help you guys out to establish those baseline readings. So if you do have any worries about establishing that baseline reading, rest assured, we're going to be here to assist you guys for that.
Yeah, we've got a whole customer success team that works in with the regional manager in your area to make sure we aren't just chucking something, as we say, over the fence, and moving on to the next. So we've got you covered in that regard. Here's an interesting question that might impact others as well. So I'm glad someone asked it. But we've got a guy saying that they just installed a bunch of RAS sensors. So those are our remote access sensors that we have, and wondering if those will function with our OnTrak system.
So unfortunately, the RAS sensors will not work with the OnTrak system. The sensors are wired into the OnTrak itself. There are some signals there that we're picking up with these sensors that we otherwise probably would not pick up with the RAS sensors. So there is a little bit more involved there. But yeah, unfortunately, no, we cannot use the RAS sensors with the OnTrak system.
All right. But we can work with folks on that. If there's a specific bearing that you want to use this OnTrak on, we can, do trade-ins and things like that.
Right, so, absolutely, right.
Yeah. Okay, the RAS sensors, of course, are really great, especially if you're doing more traditional route based on less critical assets. They're really good for your hard to access areas where you do just still want to use, a handheld grease caddy or whatnot to go do your ultrasound assisted lubrication with. So still a great sensor and a great application for it. Just does not tie in with the SmartLube. So okay, another question that we're getting, a couple of folks asking kind of different iterations of it, but I think you can handle this one, Sean, is talking about background noise. It's always kind of a concern for folks. Well, what if I've got a really noisy environment, or what if, you know, the equipment itself is really noisy? How is that going to impact the sensors being able to hear what they're supposed to be hearing, and not you know, setting the system off to grease a bearing that isn't having friction issues. It's just the environment around it is noisy.
Right, and that is a very common question. You know, being that we're in ultrasound, okay, we're listening above that human level hearing spectrum. So we can hear as humans up to about 16.7-ish kilohertz. And of course, that degrades as we get older, unfortunately. But or I just tell my wife it's selective hearing, of course. But what happens is, being that we're ultrasound and we're listening above that human level hearing spectrum, we're listening at roughly around 30 kilohertz. Okay, that is going to be our sweet spot for our bearings. And being that it's above that human level hearing spectrum, it doesn't matter if you're in a noisy environment, because ultrasound is very directional. If we're making contact with that bearing housing, right, it doesn't matter if there's a whole operation going on around it outside of it. Because we're tuned to the ultrasonic level, we are tuned specifically to listen to that bearing. So there should be no reason to worry about any kind of background noise that you might pick up from any work processes around that might interfere with your readings. So no reason to worry about that, again, because we're listening above that human level hearing spectrum.
All right, awesome. Good explanation there. Okay, so then we've got a few people asking some pretty specific questions about our single point lubricator. So maybe we can tackle these kind of all at once. So Sean, kind of the first one is how is it powered? So of course we know the single point lubricator has a battery.
Right, right. It does have now. So that single point lubricator does come with the battery. That battery, anytime if you guys did to swap or needed to swap out a grease cartridge in the OnTrak SmartLube, or the single point lubricator to be more specific, it does come with a brand new battery as well. The battery is designed to last I believe it's the lowest and slowest grease setting that you can possibly give on this single point lubricator. The battery is going to last that longest life that you can possibly throw at it. So, but either way, even when you get a brand new grease cartridge come in, it does come with the new battery. So there's no need to really worry about, you know, battery or powering issues of the single point lubricator or anything like that. It's really the OnTrak is the only thing that we're plugging into the wall.
Right. All right, cool. And then also, component of that is the grease cartridge itself. And so we've got one person asking if those pouches are refillable, and someone asking how the system knows how much remaining grease is in there. So maybe you can tackle both of those at once.
Right. Okay, so let's go ahead and tackle the how much grease is in there. And I'm going to go back a couple of slides so you guys can kind of see this. If you guys can look here on the bottom left-hand corner of your screen, you're going to see that like little blue box there kind of looks like a fill cup, right? That is your level of grease that's in the single point lubricator. So you're going to know how much grease is being used and how much grease is left in your single point lubricator. And what was the other one again? I'm sorry, Maureen.
I'm talking about whether the cartridge itself is refillable.
Oh, all right. So from what I understand, and Maureen, correct me if I'm wrong, I haven't heard much update on this, but from what I understand, I think we're going to get to a point where we can grease them ourselves. As of right now, I believe what they're doing is we're just getting the grease type manufacturer from the customer, and we are pre-filling the cartridges and sending them to the customer. Of course, when they're empty. And that's pretty much what's going on. We've had customers send barrels in to just have them reload the grease cartridges when they send barrels. But as far as just reloading them yourselves, I believe we're moving towards that, but I don't think we have anything set in stone yet.
Right. You need to have a delaminator, I believe is what it's called, in order to do that, where you're not where you're getting all the air and things like that out of it. So
right.
It is possible, but there's some extra steps involved. But the good thing about these cartridges is, you know, and again, because of what he's just showing you about knowing the remaining life of the cartridge and how much is left, you know, you've got a good enough indicator of when it's time to order a new cartridge that, you know, we can get ahead of that and there's no worries about running out. So
Right.
okay, cool. Great, great, great. Let's see. So a couple more. Oh, here's one. So someone was kind of suggesting that one of the issues they've had in the past with auto lubers is because their environment is very, very, very cold, especially in the winter, to where they just don't function. So they were wondering if it's possible to use the sensors and monitor the friction and then go do your lubrication
Yeah.
manually. So how
Yep.
about you talk about that?
Yeah, absolutely. So here, I'm going to show you guys a slide here. I'm going to go back a little bit. I apologize if I'm going back, but I want to show you guys this. So you can absolutely use this just to measure those friction levels. Kind of like you see here, you're still going to get those alarm notifications, whether it be through text or email. But then, of course, at that point in time, after receiving those texts, verify obviously your friction levels through the UE Insights, and then you can send somebody out there with that manual grease gun and manually grease that bearing. And what's cool about that too, if you're allowed to have phones obviously out there on the floor, business related, of course, you could break out the cell phone and watch those friction levels drop as you're manually greasing the bearing too. So you can do that as well. I hope that answers the question.
I'm sure it did. I'm sure it did. Okay, so just maybe, you know, there are several people kind of talking about cost, and we're not trying to hide that at all. So maybe Sean just kind of talk high level, sort of a per point cost for the SmartLube, knowing that there's definitely variables like the grease type that you're having to use, the cable lengths, the cable types. You know, there's factors that go into it that can shift the cost of this. But on average, what are we looking at per point for the OnTrak SmartLube?
Okay, so what we're seeing, if you're just going to use like maybe just the OnTrak itself, what we're seeing on average, and this of course is all contingent on cable lengths and everything, we're talking roughly at about 500 per point ish. And correct me if I'm wrong, Marie.
Yeah, we love the ish is perfect. It leaves plenty of wiggle room.
Right. Because you're right, because there's the UE insights and there's some other factors involved like cellular service and all that, and but that's pretty much the gist of it. Now, if you're using the OnTrak system with the single point lubricators, again, it's all contingent on remote lines, grease extensions, of course the line for the SmartLube lubricator as well as single point lubricator. You're looking at roughly about 650 per bearing.
Yeah, so
Ish.
it's a
Again,
great
that's
solution to pilot. You know, that's again another perk of ultrasound. You know, it is very scalable. So, you know, you can choose literally one asset that you want to test this out on, and you know, hook up. You know, maybe it's only 4 points, maybe it's six, maybe it's two.
right,
You know, whatever the
right,
case may be. And you know, you do a proof of concept. You have it running and see for yourself how it works, and then you kind of build from there. So it's really a nice
right.
kind of perk of ultrasound and this system for sure.
Right, and it's modular too. So like she said, you could start on something small, and you know if you thought that you could benefit from it, you can expand upon that, add more sensors to the one OnTrak that you have potentially.
Yeah, perfect. Okay, so just to kind of wrap up, so just to hit a few of the other questions that I'm seeing quite a few times is, yes, we did record this, so we'll make that available to you. If you're interested in the presentation itself, shoot either Sean or myself or just the info at UE Systems, wherever. Just get in touch with us, and we'll work with you to get the information that you're looking for on that. those of you that are wanting more information, of course, we'll follow up. Those of you that we didn't get to your questions, some of them are just better left to have conversations offline. So we'll be sure that you hear from us, whether it's Sean or someone else from the team. So we'll get those things answered for you. But we really appreciate you guys taking the time today to join us. We're really excited about this. We're loving the feedback we're getting on it. We encourage it. It helps us to think things we maybe hadn't thought about, and applications we weren't thinking about, and things like that. So it really is kind of a group project, where we're all working together to hopefully come out with the best solution for you and your specific application. And as Sean said, we are 100% here to be a partner with you in this. It's not something that we're going to just wash our hands of it as we get the product out the door. We're only successful if you all are successful with it. So know that's something we stand by and are proud of. So again, thanks for being here with us, Sean. Awesome job. Great information. Really appreciated it. And we'll let you all go. Enjoy the rest of your day. We've got lots of other webinars and things coming up, so just keep an eye on our LinkedIn page. It's a great place to get lots of information. So just follow, if you're not following our UE Systems LinkedIn page, highly recommend it. And get connected with Sean. He's always sharing a lot of good information as well on LinkedIn. And we will catch you guys later.
Thanks, guys. Have a good one.